Hey guys, so if you've seen the review video, this is going to a little bit more depth than what we covered in class. So now we're just rotating this shape over, instead of the y-axis, the x-axis. The same exact shape, same exact curve, y equals x plus 1 and y equals x minus 1 squared. Okay, so the first thing I've done here is I've drawn a picture and I've drawn our cylinders, right? In this case, this is what our cylinders are going to look like, okay? Cylinders are going to be oriented like this, there's one of them, and the other one would be, like this, and then there's going to be some smaller ones in here, and so on and so forth. So you can tell that the radius is, it's increasing upwards, right? It's increasing like this, and then there's the next one, and then there's the next one, and so on and so forth, okay? So what does that mean? That means that in this equation, this is the equation for finding the volume using the shell method. Our r of t, in this case, is going to be a function of y. It's going to be y, right? So it's going to be 2 pi integral y, okay? And now our height. Now we're going to have to get to height, okay? Now we'll talk about height. Okay, so before we do that, before we get to height, we know it's going to be dy, and we know that the bounds are going to be over y. Okay, so there's something interesting about this problem, okay? And that's this. So let's just get rid of the clutter here. You guys know that what we're dealing with here is cylinders, but let's just look at this 2D. It's a bit simpler to take a 2D look at things. Okay, so here are two of our rectangles, two of the cylinder sort of cross sections at this point, okay? And you can see, we can tell that, whoops, got rid of the axis by accident. You can tell that the radii here r equals y, right? Okay, so what about this height? What does the height equal? Well, here it's pretty simple, right? The height is just this minus this, right? The height in this case is an x distance, okay? It's an x distance, not a y distance. So it's x at this point, let's call this x2, and then minus x at this point. Let's call this x1. x2 minus x1, okay? x2 is on the curve y equals x minus 1 squared. And x1 is on the curve y equals x plus 1. So because we're integrating over y, we need to have the x value of these curves in terms of the y value, okay? Basically, in order to do that, we just take the inverse, right? And switch the variables. Okay, we take the inverse and switch the variables, which just means that instead of saying y equals x minus 1 squared, we say instead that root y plus 1 equals x. And that's x2, right? Y is the y that we're integrating over. And then instead of saying this, we say y minus 1 equals x1. Okay, so now we have the height for this guy here, okay? But now let's say I'm looking at a different cross section, okay? Let's say I want to look at this cross section instead, okay? Let's make this a bit bigger. Okay, let's say I want to look at this cross section instead, all right? And this is, of course, as you guys know, this is like a cross section of the bigger cylinder, right? The bigger cylindrical shell. In this case, what's the height? Well, this is x2. And this is x1, whoops. But in this case, x2 and x1 are both on y equals x minus 1 squared. And why is that? Well, it's because this parabola isn't a one-to-one function, right? You can't take the inverse of a parabola, You remember the horizontal line test? If you draw a horizontal line, it crosses with itself. So for the issue here is that for a given y value, the parabola has two x values, okay? Which is something we're going to have to deal with, okay? So this is not entirely accurate, right? What the inverse of this actually be? We have y equals x minus 1 squared, so plus minus the square root of y equals x minus 1. So x equals plus minus square root of y plus 1. Okay, so we see that, let's draw a line here, okay? We see that over this section, yeah, let's look at this graph actually. This one's a bit cleaner. Over this section, we see that the x2 and the x1, to find the height, are both on the parabola. But in this section, it's not the case, okay? Right? The x2 is on the parabola and x1 is on the line, right? So, in order to find the volume here, we're going to split this integral up, okay? And how do we split this up? Okay, well, from here to here, what are the y values? These are negative, these are just, this is just the mirror, but it doesn't matter. From here to here, we go from 0 to 1, right? Let's try to sort of make this clear, okay? We're just kind of tidy things up a little bit. Okay. So we have these 2 points of intersection, right? We have this point of intersection here, and this point of intersection at the upper end, okay? So the y in the y's in the blue section are from y equals 0 to y equals 1, and then in the red section, we're going from y equals 1 to y equals 4, okay? All right. So basically, we have two integrals that we need to take, we need to form to figure out the volume of this entire shape, okay? Let's look at the blue part first, the blue region. All right, actually, let's look at the simpler region. Let's look at the red region, all right? For the red region, we said we have 2 pi times the integral of y. Radius is y regardless of where you are, okay? And the height, in this case, well, the upper bound of the height is on the parabola, the lower bound is on this little thing here, okay? So, is on the line, okay? So the upper bound is on the parabola, the inverse of a parabola is root y plus 1, okay? And then minus y plus 1. Y minus 1, okay? dy from y going from where? 0 to 1 as we said, right? Sorry, 1 to 4 as we said. 1 to 4. This is the red region we're talking about here, okay? The red region from 1 to 4, and it's just the parabola minus the line, okay? In this case, we're taking the positive here, okay? Because if you try to sort of orient yourself, try to flip it around, this is square root of y plus 1 we need to take positive square root of y, because square root of y is higher than the y minus 1, right? Minus y minus 1 here. Okay. And here's our first integral. Now for the blue region, if you remember, we split this up into two sort of possible x's, right? We can get, we split x minus 1 squared into plus minus root y plus 1. So it's really root y plus 1 and minus root y plus 1. So in this case, it's going to be integral from 2 pi, 0 to 1, of y, again, radius is y, times the height. Okay, so the higher one is clearly root y plus 1, right? Here, here, this is root y plus 1, and this is minus root y plus 1. And you can just tell because, this is bigger than this, right? This is a bigger x value than this. So basically what you get is root y plus 1 minus root y plus 1. Okay? And then what you do is You add these up, and then you get your final volume, okay? All right, done.